Deep inside this data center, a global Fortune 500 AI deployment is actively losing money on every single call. The operation is vast, attempting to process hundreds of thousands of conversational voice surveys simultaneously. Each call interprets human speech, analyzes sentiment, and generates dynamic follow-up questions in real time. But the system is struggling under its own weight, trapped in a computational loop of invisible thinking tokens. To categorize a simple yes or no response, the platform routes the prompt through a massive flagship model. Before outputting a single word of audio, that model generates up to 15,000 tokens of internal reasoning. These steps never reach the user, but the API provider bills for every one of them. The sheer compute draw is maxing out the hardware, pushing the thermal limits of the facility, and drawing massive amounts of power from the grid to process simple survey answers. Applying high-end reasoning models to high-volume routine tasks creates an overhead that can deplete a research budget before the first wave of data is even collected. That overhead is a direct result of how these models are built. They are designed as highly aligned, general-purpose engines carrying the computational weight of billions of parameters. To achieve that level of alignment, developers use reinforcement learning from human feedback. This process requires thousands of human labelers to manually rank responses, teaching the model how to follow complex instructions safely. Relying on these models for narrow tasks means paying for a massive physical and human infrastructure that provides no additional value to the specific survey being conducted. To stop the losses, the engineering team pauses the deployment. They move to a glass board to audit the true economics of their technology stack. This cost asymmetry means generating an output token requires significantly more GPU compute than processing an input prompt. Producing text is 8 times higher than reading it. When 15,000 tokens of invisible reasoning are generated, the cost per call spikes exponentially, evaporating the budget. The solution requires abandoning this single model approach in favor of a full-stack agentic architecture that breaks the workload into specialized segments. Operational efficiency at this scale depends on separating complex, high-stakes reasoning from routine, high-volume processing. For the high-volume voice survey processing, the engineers replace the flagship model with a DeepSeek Mixture of Experts, or MOE model. While the model contains 671 billion parameters, it routes queries to a specialized subset, activating only 37 billion. Context caching reuses repeated inputs, bypassing processing and reducing compute by 90%. Next, 8-bit quantization compresses internal data, accelerating inference speed while maintaining accuracy. With the routine volume optimized, the engineers route only the rare, highly complex respondent interactions back to a reasoning-heavy model. Combining a mixture of experts architecture with context caching removes the direct correlation between AI scaling and AI expense. To manage the new workflow, the engineers deploy an agent orchestrator. It acts as a traffic director, routing each survey task to the correct model based on the complexity of the interaction. This enterprise framework shows that secure, autonomous deployment relies on 4 layers: unified knowledge, optimized models, agent orchestration, and operational governance. The model optimization layer allows benchmarking and swapping between language models for specific tasks, controlling both latency and cost. With the orchestrator active, the system stabilizes. Server temperatures drop and the survey goes live, handling parallel calls within the original budget. A network of low-cost agents provides the economic balance to reach millions of respondents without inflating the cost per insight. Across thousands of live connections, the AI conducts the surveys with high accuracy. It interprets spoken answers and logs the data instantly, sounding natural to the people on the other end. Instead of spending thousands of dollars on internal reasoning, the system now processes each interview for a fraction of the original cost. The latency has dropped and the data flows directly into the company's analytics tools. Scaling enterprise AI successfully requires a move toward unified platforms and specialized architectures that prioritize operational efficiency over the raw size of a single model.